Okay, here we go. All right, yesterday we said that quadratics are f of x. This is kind of like a review. Are ax squared plus bx plus c. Definitely take notes. I try to be very clear with these today. That's a quadratic. So for example, this right here is a quadratic. It's a quadratic function. Quadratic function. There it is, okay? Now, you know, that's a quadratic function for sure, but I want you to have, yesterday's lesson taught us that you'll have three pictures in your mind. The first picture you should have in your mind is, does it look like this or this? Again, this discussion is not the way typically you're taught it, but it will really help you to learn it fast, no matter how you were taught it. And it also gets you ready for the SAT. So I'm gonna call this case one. Shout out to my good buddy, I think you might know Anthony, my good buddy, Miss Pope, for parts of this discussion. Her and I talked about this about 5 years ago, and we haven't seen it in any textbook. We just joked about it about a month ago. But this is case one. In case one, we have two solutions. Again, borrowing from yesterday's lesson. Point A and B, point A prime and B prime. The only difference between these two cases, the only difference is that A is less than zero, meaning this could be a negative here. So this is A. A is the number before the x squared. If that number is negative, then it looks like this. And that's the way they're going to hit you on the SAT. Which one is most likely to be it, right? It's most likely that it's this curve over here, right? Because this one is when A is great. I said that wrong, y'all. This over here is A less than zero. Please correct that. This is A less than zero. Over here is A greater than zero. And this is more likely like that, right? Now, it could be, over here on the negative side or positive side, halfway on both sides. But A and B are what we call solutions to the quadratic. The second possibility is case two. Case two says there's one solution. I'm going to call this point A. So this one shows A greater than zero. This one down here will be A less than zero. But this is an example, point A, like I said, where there's only one solution. One solution. So far, we're in the realm of real solutions. There's either one real solution or two real solutions. Fortunately for you, on the SAT, that's all they care about, is real solutions. One solution or two solutions. Now we get into the world of case three. But before we do that, I want to remind you that A and B are solutions. They're also called zeros. And the reason they're called zeros is because no matter what these points are, if this is 5, this is 2, then this is 2, 0, and this is 5, 0. That's why they're called zeros. The term zeros, we didn't get to this summer because I decided to cover more of the trig stuff. Polynomials is where you hear zeros more, but you'll hear it occasionally used for quadratics as well. In other words, looking at this equation, what are the values for x where f of x is equal to 0? Okay? Which suggests that the first step to finding out a and b, which ends with factoring, is to set f of x equal to 0. And you're going to see something like that on the review sheet that will release tomorrow. And it's not mandatory, but we like you to look at it and send us your answers so we can help you, and even help you to understand why you got any wrong or couldn't do any of them. It's fine. And they'll be only on the stuff I covered. All right, so this is case 1 and case 2. Case 3 of f of x equals ax squared plus bx plus c. Case 3, whoops. Case 3, let me erase that line. Okay, it's kind of sad. Okay. Case 3, much. Case 3, this is y, and this is x, is something like this. Or maybe like this. This is a greater than 0. This is a less than 0. But you can see there's no solutions. Neither of these curves touches the x-axis. So there are no zeros. No solutions. But now I'm going to have you put one word in here. There are no real zeros. There are no real solutions. In other words, there's no real number that can make this equal to 0. But there are imaginary numbers, probably 2. You can see for this it's 2. There's 2 imaginary numbers that could make this the answer. We're going to look at that today. All right. All right, no zeros, no real solutions. That's what we're going to talk about today. Now, I will say factoring still gets you there, but it's not the kind of factoring you can do like you do for real numbers. We have to use what's called the quadratic formula. And I'm going to talk to you about that in about, a few minutes, maybe about 12 minutes or so. What I want to do first is talk about imaginary numbers. Let me find out, before I do this, some of you may have covered it in Math 2. Let me put this down. Imaginary numbers, okay? This is supposed to be a B here. Okay. Imaginary numbers. Let's find out. Terrence, did you all talk about imaginary numbers?
No, I don't think so, but maybe once you go through it, I might.
Yeah, that's right. Good. Let me know if you feel that way. I'll ask again later. Anthony, do you remember covering this?
A little bit.
A little bit. Okay. I'm just trying to deal with the assumptions we make on the outside of school, okay? All right, let's take a look at what an imaginary number is. The best way to know what an imaginary number is to tell you about a problem we have. Let's say we want to know the square root of 16. Well, the square root of 16 is going to be plus or minus 4 because minus 4 squared is 16. 4 squared is also 16. So when you take the square root of 16, you get plus or minus 4. Okay? And that's true of any square root. I mean, square root of 81. Plus or minus 9. Okay? Plus or minus 9. So if we have x squared, write this example down, minus 9, excuse me, could you make that minus 81? x squared minus 81 equals 0. And if we have this and you want to solve it, you first set f of x equal to 0, which means then you have 0 equals x squared minus 81. Again, the reason you set it equal to 0 because you want to find out what are the x values when y is 0 and y is f of x. Somewhere somebody keeps telling you that y is f of x. All right, solving this, we can factor it. You can factor it as x plus 9 times x minus 9. Well, in the first case, we get that x plus 9 equals 0 and x equals minus 9. I'll call it x1. And over here, you can see by the same reason, x2 is 9, because 9 minus 9 is 0, minus 9 plus 9 is 0. All right, so what we have here is a solution set. Then you just do like this. We can't do what I do. Minus 9 and plus 9. And so that's why this is true. So the square root of 81 is plus or minus 9. All right, this is all stuff you know already. These are about real numbers. Now I'm going to take a little turn here. I'm deliberately going to a new page. This is an explanation of square roots, why we have plus or minus square roots. There's another aspect of these that I should tell you. Let's say you have the square root of 20. Okay? I think you probably covered this before, but you could write this as the square root of 4 times the square root of 5. The only thing I'm going to add is plus or minus. Okay, let me get that out of the way so you can see it better. So I want to make it clearer. This is equal to plus or minus square root of 4, square root of 5. You can break it up into parts such that the left part is a perfect square. And you keep doing that till you get it reduced down. You have a couple of problems like that. Well, we'll do some exercise on it later. Square root of 4 is 2, so the final answer is plus or minus 2 radical 5. The only difference between this answer and this answer is that this is called irrational. Irrational means that you have at least one factor that you can't represent as one number divided by another number. Square root of 5 is weird. It's 2.2 something that goes out for like 200 decimal places. So it's an irrational number. So plus or minus 2 radical 5 is the square root of 20. But these are all still real numbers. Whether they're rational, like 9, or irrational with the square root of 5. These particular things are still real. But listen closely. They're the only way that I can help you to understand the need for, or the relevant, not need for, strike that, is how we get imaginary numbers. I have to go through this. Next page. Let's say instead of square root of 16, we have the square root of negative 16. Well, the question is, what number do you multiply by itself that gives us a negative number? The answer is it can never be true. So the right answer here is empty set. There's no number you can multiply itself by itself and get a negative. A negative times a negative is a positive. Remember that. A positive times a positive is a positive. There's no way to get a real number. No real number answer. Now we're going to imagine a world where we could break this square root down into 2 parts like we did before, right? You would have the square root of 16, right, times the square root of negative 1. Because if you multiply 16 and negative 1, you get minus 16, which is what we have here. Any questions on that? So the answer would become 4 times the square root of negative 1. Now, let me do another one. square root of negative 20. Well, let's break that up into parts. Again, you got to deal with that negative. This means you're going to have the square root of negative 1 in there. Okay, we have the square root of 4 times the square root of 5, which is the real part. And then you have the square root of negative 1. 4 times 5 is 20. 20 times negative 1 is minus 20. Okay, which is what we're dealing with. Next, we get 2 radical 5, right? We should say plus or minus. Sorry about that. This should be plus or minus up here too. I didn't do that. Plus or minus 2 radical 5 times the square root of negative 1. So it seems like we're always going to have this square. Let's do another one. Square root of negative 36. Well, square root of 36 times the square root of negative 1. And we get 6 times, plus or minus 6 times the square root of negative 1. Oh, wow. So we're always going to have this square root of negative 1 component. You see it? You're always going to have it when you're doing the square root of a negative number. I'm going to say that again twice. Whenever you take the square root of a negative number, you're always going to have that negative 1 component. Square root of negative 1, okay? Now, in mathematics, we love, if you go back to ancient math, I think back in Egypt or even ancient Greece, they would just leave the negative 1 in there, and they would just imagine that world. Well, we decided around 1400 or so to give it a symbol. That symbol is I. So I equals the square root of negative 1. Write that down. That's important. Using our newfound knowledge, let's take the square root of 72, negative 72. The square root of negative 72. All right, what does that equal? Equals the square root of 36, because I know this is going to be a perfect square root. What you have left over, 2, is 36 times 2, 72. Times the square root of negative 1, or we could simply say 6 plus or minus square root of 2, I. So I is the square root of negative 1. I is equal to the square root of negative 1. That's huge. And this is a overview, a teaching on imaginary numbers, what I think they should give you in school before I even go to getting solutions. Okay? This is the realm of what we talk about when we say there's not a real answer to this question right here. There's not a real answer to it. Okay? All right, let's go on over to talking about that I squared. I is the square root of negative 1. I'm getting ahead of myself. So I need you to know, coming from that, the first 4. I squared is equal to negative 1. Why? Because if you square, I'll put the y over here. If you put negative 1, square root of negative 1, times the square root of negative 1, clearly you get negative 1. So I squared is negative 1. I cubed, if you will, is equal to, give the explanation, I squared times I. Out of the first, if you want. Because 2 plus 1 is 3. I squared is negative 1. So negative I is the answer for I cubed. Finally, I to the 4th. I to the 4th power is I squared. Let's get the explanation first. I squared times I squared, which is minus 1 times minus 1, which is 1. So if you take I to the 4th power, you get 1. Now, I'm not going to belabor this, but I can predict what 5, 6, 7, and 8 will be. You just start over again. I to the 5th is equal to the square root of -1. You can prove it because it'd be 1 times the square root of -1. So you get simply I. So I to the 5th is I, which shouldn't surprise you because that's what we have there. Okay? I is just I. I to the 6th we can predict is -1. I'm not going to bother to figure it out. I to the 7th, I to the 7th power is minus I. And I to the 8th power is I. So you can see that they repeat, which means you can predict things like, what is I to the 240th power? That's enough. What is I to the 10th power? Oops. Back, let's do that one first. I to the 10th power. Well, we know that I to the 8th power, it's I to the 8th power times I squared, right? And I to the 8th power is a multiple of 4. You can see that, right? As a multiple of 4, it's the 4th one. I didn't do it right. The 4th one is 1. Sorry about that. Wreck your notes. So it's going to be 1 times I squared, or 1 times -1. 1 times negative, which is -1. So I to the 10th power is -1. Again, how do we do it? We can break it up. The better way to look at it is, what's the next multiple of 4 that's below I to the 8th? Meaning take 10, divided by 4, you get 2. Right? So 4 times 2 is 8. So you know that 8 is the closest one. And again, you're going to get practice on this in school. I'll have maybe 1 or 2 easier ones on my sheet at the end, but pretty straightforward. So the answer to this question, what I to the 10th is, it's -1. Think about it this way. You get to 8, it's like getting here. Then you go down 2 levels and you got it. Go down 1 level and you got it. I squared. Okay. All right, let's look at I to the 240th power. Well, 240 divided by 4 is a whole number 60. So you can see it's a multiple of 4. So since it's a multiple of 4, that's where my answer is. The answer is 1. And if it had been I to the 241, the answer would be the next one, which is I. So you look for that multiple of 4. One more. I to the 30th power. And this is not directly important. I don't know why they spend so much time on it. I'm just spending enough time so you can recognize it in class. It's never going to be used anywhere else. Well, certainly not for solving quadratics. But let's do I to the 30th. Well, 30 divided by 4 is over 6. It's 7 plus 2 places down. So at 7, which is a multiple of 4, we're going to be here. We're going to be at I. Then 2 more down, right? 1, 2. Right. So at I to the 28th we're here. I to the 29th we're here. I to the 30th we're here. So the answer is minus I. All right, just have that in your notes. I don't think it's not central to our discussion. The central part is what I covered just a minute ago when I was taking the square roots over here. It's like an optional topic. Let's get back to that in fact. Let's suppose we have f of x equals x squared, which is where we were yesterday, plus 25. And we said that this does not have a real solution. Let me show you what I mean. We set it equal to 0. Subtract 25 from both sides. Just remember, we can't factor it. That's a positive. If it was a negative, we could factor it, right? So then we get minus 25 equals x squared. When you take the square root of both sides, you can see right here we got a problem. The square root of 25 is the square root of -1. or what? Or 5i, plus or minus 5i is x. So this does have an imaginary solution because of that positive in the middle. Let's try another one. Keep it real simple at first. F of x equals x squared plus 36. All right, set it equal to 0. I did this side instead, okay. Set it equal to 0. Then x squared is negative 36, which means that x is equal to plus or minus 6i. AJ's here. It's plus or minus 6i, okay? So plus or minus 6i. All right, why don't you guys try this one now? F of x equals x squared plus 4. Everybody work on that one. Solve for x. That's where they're going to come at you. They're going to say solve for x. And there's no real answer. There's only an imaginary answer. I'll wait. What's the answer to this one? Who can say it exactly right? Terrence, do you know where to start? Terrence, you know where to start here? Would be a good first step.
Would I subtract 4 to the other side?
Well, you don't have anything, so you got to make it equal. Make it 0 first, right?
Okay.
There's nowhere to go. Now what do you do? Oh, by the way, Terrence, before you start, why did I make f of x 0?
So I can subtract 4 to the other side?
That's
I don't
the
know.
most practical answer you can give. But also, Anthony, do you know why I did it? What gave me the authority to do it?
I don't know.
Because this picture gave me the authority. We want the values that are zeros. We want to know where f of x equals 0. So the way to find out is to make f of x equal to 0. But Terrence, that is right. You want to have something to solve. But this is what gave you the authority. Now, Terrence, what do we do next?
I'll use the
Subtract
imaginary.
4. Subtract 4.
Yeah. Subtract 4 to the other side.
Right. I just said it was the wrong step, that's all. So minus 4 equals x squared. Now what?
I would use the imaginary numbers, right?
And how do you use it here?
To get the exponent away from x and isolate it.
There you go. So you take the square root of both sides. And what do we get from that? What do we get on the left side?
2 or 2i.
Very good.
And
I equals
equal
x.
plus or, yeah.
What'd you say?
I was gonna say plus or minus
Perfect. You're done.
x.
Perfect. You're done. Okay. Just remember
Okay.
that's that equal to 0 step. Sounds like you're going to be fine. Let's try
Okay.
one more. I got to erase those. Sorry, guys. I don't want to lose the whole board, so here I am, erasing the whole half. Okay. Here's one here. F of x, oops. I don't have my pen here. F of x is equal to, let's make it interesting. 2y is equal to 2y is equal to what I want to do here. I forgot what I'm doing here. Well, I guess we can't do that. Hold on. I got to save that. We haven't done. We got something else we got to learn first. Sorry. I'm keeping it real simple. I forgot. That's the way they're going to come at you. They're going to start real simple. So that's what I'm trying to do. Let's say that f of x equals x squared plus 200. Everybody write that down. Why don't you try it first, see what happens? Everybody try this one first and see what happens. F of x equals x squared plus 200. Try it first. Give you about a minute or so. By the way, for AJ just came in, just watch for a bit. And we're going to finish up. Looks like we're on schedule to finish up today a little early, about 10:20 or 10:15 for our last class. And I'll tell you what's going to happen right before we break. F of x equals x squared plus 200. All right. All right. What's my first step, Anthony?
Make f of x 0.
Now what?
Minus 200.
Now what?
You use the square root.
Correct. Now what?
Then you do plus minus 200i.
Square root of 200.
Yeah.
Is there any way to break it down further? So this, by the way, Anthony, this is not wrong. It's just that some picky teachers want you to break that 200 down. What's the closest square root that goes evenly into 200?
Use 10 and 20, I think.
Right, 10. So you say the square root of 100 times the square root of 2 times I equals x. See it?
Yeah.
So what's the square root of 100?
10.
Plus or minus 10, square root of 2i. That's the answer teachers will want. So this is a 10-point problem. You might take off 2 points for not going all the way. But you definitely understand it because you got here, right? But make sure you can get there, right? I mean, the square root is not 200i, it's the square root of 200i. Which means this is not only imaginary, not gentlemen, it's not only imaginary, but it's also irrational. What makes it irrational? The square root of 2 right here. Okay? Let's do another. F of x equals x squared plus, let's do 48. X squared plus 48. Okay? Let's try that for a second. Give you a minute. And now we're using imaginary numbers to solve quadratics. All right. Another 20 seconds or so. All right. So we set this equal to 0 first. I'll walk through this one with you. Now watch this, everybody. You subtract 48 from both sides. You get minus 48 is equal to, remember those cancel, x squared, or the square root of negative 48 equals x. Or, yeah. You could say the square root of negative 48i equals x. The question is, what happens with this? I say you break it up. Square root of 16, square root of 3, because 16 times 3 is 48. Times I equals x. Or 4 plus or minus, should have said plus or minus here, right? 4, just your final answer, make sure you get it. Radical 3i equals x. X is plus or minus 4 radical 3i. Some teachers will accept, most teachers will accept that. Some will want you to say, what are the ordered pairs? Well, here's the first ordered pair. Plus 4 square root of 3, comma 0, I, comma 0. That's one. The other one is minus 4 square root of 3i, comma 0. Remember, you're saying there's two imaginary solutions here. It's 2. Still 2 like it was a quadratic, but they're imaginary, okay? Because they don't touch the x-axis. The 2 solutions, okay? All right. So there's a study there. But let's take a look at, and you want to keep these notes. It will help you with the worksheets for sure. I'm going to give you a worksheet of about maybe 12 problems to cover what we covered at the end here. All right, let's take a look at something a little more complex. F of x equals x squared plus x minus 20. Plus 20. Sorry, guys. So you might say I would try to factor this, but there's no factors of 20 that will give you 1 right here. You try the X method, all that, because these two things are plus here. There's no way to get it. Just like when we had x squared plus 16. if it was minus, you could do this. X plus 4, x minus 4. So here, clearly, we've got to use what's called the quadratic formula. And in this problem, a equals 1. You might want to stop and assess that to make sure you do it right. By the way, whenever you see C is much greater than A and B, you probably have imaginary solutions. Probably 2. If it's like 8 or something, it's closer. Remember, these are squares. You're still going to have 2 solutions, but the curve will look different. That's not important. Important thing to know is when C is much greater than A and B, in this case 20 times greater, you're likely to have an imaginary solution. Remember, minus 20 doesn't count because you could factor this if it was minus 20. You do 5 and negative 4. All right, so the quadratic formula says that write this down. The 2 solutions for x will always equal to plus or minus, no, will be minus b plus or minus b squared minus 4ac all over 2a. Okay, so I want you to focus your attention on what I've circled. Because if what I've circled is negative, you have an imaginary solution. Because you'd have the square root of a negative number, wouldn't you? So if, write this down, if b squared minus 4ac is less than 0, you have 2 imaginary solutions. If b squared minus 4ac is equal to 0, you have 1 real solution. If b squared minus 4ac is greater than 0, you have 2 real solutions. It's a good summary of what we've been doing here. B squared minus 4ac is called, there's a name for it, the determinant. Let's check back in. Terrence, does this ring a bell?
No, not at
No.
all.
Yeah, some people just didn't cover an algebra 2. They didn't cover that. About you, Anthony? Did you see this before, Anthony?
No.
Yeah. AJ, we didn't quite see this in math too, did we?
I think I saw it before.
Somewhere.
Yeah.
Love this. Yeah, because it wasn't really that important for those, but it's real important for pre-calc. It's a big part of understanding pre-calc polynomial solutions, and those solutions then later on trig equations. At the very end of the class, you're doing polar coordinates. So it's kind of also in physics. If you ever take physics, it becomes important. I don't know who's had it and who hasn't. All right, okay, so the determinant is b squared minus 4ac. If it's less than 0, we have 2 imaginary solutions. If it's equal to 0, we have 1 solution. If it's greater than 0, we have 2 real solutions. So it's almost like how we started today. In this one here, curves are like this, right? They don't touch the x-axis. And this one here touches at one point. These are the pictures that should be in your mind. And this one here, it touches like this. Touches 2 places. Or it touches 2 places like this. But that's all some people say you should do the determinant first. And that's what I'm going to do on this problem. When I go to the next page, I'm going to do the same. I'm going to solve this equation using the quadratic formula. That's what this is called. Quadratic formula. But I'm going to make sure that I do the determinant first to see which one of these 3 cases I have. We started with 3 cases today. All right, let's go to the next page. So we have 0 equals x squared plus x plus 20. I said f of x equal to 0, right? So we need the quadratic formula. Let's first figure out what b squared minus 4ac equals. Then we can deal with the quadratic formula, which is here. Minus b plus or minus that right here, all over 2a. So we're going to do that right there first. So we do it first, and what do we get? We get 1 squared minus 4 times 1 times 20. Remember I told you if c is much greater, look what it does. 1 minus 80. Because when you do this times 1, it's minus 4. This times 20, it's minus 80. So 1 minus 80, we get an ugly answer, I'm so glad, of minus 79. So let's do the quadratic formula with that equal minus 79. x12 is minus 1 plus or minus the square root of negative 79 all over 2 times 1, which is 2. Well, the square root of negative 79 is just the square root of 79i, right? The square root of negative 79 is the square root of 79 times the square root of negative 1, or the square root of 79i. So we get minus 1 plus or minus the square root of 79i over 2. Dividing this thing out by 2 to each term, get minus 1/2 plus 1/2 square root of 79i, and minus 1/2 minus. This is plus or minus. This ugly answer is the answer. So this right here has a very ugly imaginary solution. Okay? Let's take one a little more believable. That one I just put up there. And then maybe we'll try one yourself, and then we'll call it quits. There is f of x equals x squared plus x again plus 4. Okay, so we set it equal to 0. There it is. All right. Quadratic formula. Let's do b squared minus 4ac first to see if we have an imaginary solution. Well, it's 1 squared, so you can already see 1 and 4, minus 4 times 1 times 4. Oh, I like this one. You get 1 minus 16, which is negative 15, which tells me I have 2 imaginary solutions. Okay? So that means that my quadratic formula, x1 and 2, minus b, which is 1, plus or minus the square root of minus 15, which we got right here, all over 2. So then we get minus 1 plus or minus square root of 15 times I, right? There's nothing we can do with square root of 15. Most times in these problems I'm going to give, you can do something with square root of 15. Like if it was square root of 8, you could have square root of 4, square root of 2. You could. All over 2, which gives us minus 1/2 plus or minus 1/2 square root of 15. Again, it's 2 solutions. Got a little internet stability for a minute. Should be back now. It's minus 1/2 plus. This is plus or minus, right? Minus 1/2 plus 1/2 square root of 59. It's minus 1/2 minus square root of 59. All right. Try this for 1 second as a last problem. So I wanted you to get these in your notes. So I'll just give you a couple problems to do on these in your worksheet. Put this one down here. F of x equals 2x squared plus x minus 20. think that will still cause a problem. Okay, it might. See, it's gonna make it plus. I'm sorry, I'm tripping. 2x squared, this should be squared. I'm really tripping. 2x squared plus x plus 20. All right. I'll give you the first step, then you give me succeeding. 0 is 2x squared plus x plus 20. Okay. I want you all to figure out what b squared minus 4ac is. This is a, b, c. Figure that out. Is it going to be greater than 0, equal to 0, or less than 0? Go ahead. And I'll change one thing about it. Compute b squared minus 4ac, which is the determinant. Probably have a homework assignment or two like this. Thus, they just find the determinant and tell us whether it's two real solutions, two imaginary solutions, or one solution. One real solution. It's always going to be squares. With higher powers, you could have other combinations. What's b squared minus 4ac? Take another 40 seconds. All right, anybody got an answer? AJ, do you have an answer? First time I called him. Or b squared minus 4ac?
No.
Okay. Take another 30 seconds. It's 1 squared, so that's 1 right here, right? Minus 4 times 2, right? Times 20. Anthony, you got it?
No.
Okay. Come on. Terrence, what about you?
I'm still working it out.
Okay, I'll wait. AJ?
Is it negative 159?
Yep. Why? Because it's 1 minus 8 times 20, which is 160. So that means the solution is going to be x12 is minus b minus 1 plus or minus the square root of negative 159 over 2 times 2 this time 4. This gives us minus 1/4 plus or minus 1/4 the square root of 159, which is ugly, I. I deliberately pick ones that were ugly to make sure you know how to do it. Okay, so there's gonna be a lot of that type of stuff in pre-calc, finding advanced solutions to quadratics. In case you're wondering, this is not on the SAT, although being aware of whether you have a real or an imaginary solution, b squared minus 4ac, is on the test. They never will ask you the solution if it's an imaginary one, okay? All right, here's what's going to happen from here. From here, Chisamon will send you, because I'm going to send it to her, a brief evaluation test. A lot of your parents have asked me for additional services we might render during the year to help you with your homework. And this will help me to know the kind of resources I need to provide to get you guys the help you need while you're taking pre-calc. I have to say this year, I saw more pre-calc failures and Ds than I've ever seen. And I think it's something to do with during the pandemic. You guys were taking algebra during the pandemic unless I can't subtract. And I know that when they were teaching algebra online, I saw all kind of weird. They didn't use boards like I'm doing. They sent you the videos, look at videos. And I just can't imagine how you guys learned algebra, that the way that other students learned it before you. So we're going to be here to offer online assistance for advanced math and advanced physics, advanced sciences in a way we never have before. But it will help me if you'll do the evaluation that Chisholm gives you. Now, if you try the problems and you can't do them, just say, I tried, I couldn't do it. Just say, couldn't, leave it blank, you couldn't do it. And then when you can do the problems, work them out, try to show your work, send her a picture, then she'll send them on to me, and then I'll be able to properly assist your parents with, in some cases, very low cost homework assistance. Because I want to see students, do well in advanced math. Let me find out, what kind of career you're interested in, Anthony? What kind of career?
I don't know.
What do you like?
Other than like basketball,
Yeah,
like maybe like engineering or something.
yeah, something with tech, right? AJ,
Yeah.
I think we already talked about this, didn't we? AJ?
Yeah, I think so.
Hey, what'd you think about the visit, real quick, to the Air Force Base?
It was pretty cool.
It's really interesting, huh?
Yeah.
Yeah. I got a cat I want you to meet too that balled in high school, went to tech. I want y'all, maybe I get all three of y'all to kind of get a chance to meet him. I'm gonna figure that out, okay? His name is Colby. He's a bad dude. He was a starter for Sarah High School, and now he's an engineer for NASA. He can't tell me what he's doing though. I think it's something to do with the Defense Department, whatever. But anyway, I want y'all to meet him because you guys' situations so remind me of him. Hey, Terrence, what do you want to do?
Either something to do with like business
Oh, like
or
mhm.
yeah, or like basketball.
Business administration?
I guess like kind of I don't want to like work for anyone. I want to like be able to do whatever I want.
We gotta have capital, so you gotta start by working with people.
Yeah, but
Get your
it's
knowledge up, and boom, you can make that move, man.
mhm.
I got students doing that too. I got two students that are, what do you call, assistant athletic directors who run the business. Remember, there are different assistant athletic directors. You know that, right? Some of them run the business of the Division I, Division II athletics on the campus. The business, like buying things, arranging the budget, getting the air tickets, just getting things organized. That's great training for doing your own thing. I think you can go into agenting, you can go into assisting agents, all that kind. Anyway, I love thinking about career. All right, but all these could involve some math, and that's why this is relevant this year. What you do in pre-calc or math 3, depending on what it is you're taking. Okay, Terrence, what school do you go to? I forgot.
Pacifica Christian, the one in
That's
Santa
right. That's right.
Monica.
That's right.
Mhm.
I won't forget again. I promise. All
It's
right.
okay.
Give shout outs to your parents for me. Tell them to watch your email. I'll definitely, you all get exclusive. If everything works out right, I will do all the advanced math work, or at least I may have 2 people assisting me, and I'm carefully handpick them. I got this one guy I'm interviewing tomorrow. He looks really good and sharp. And then I'll see if I can arrange something for you guys, particularly to meet with Colby Warfield. He's committed to me to do video interview, and I think I can nail him for other stuff. He went through my program, went to Sarah. He was second team all, no, his first team all his conference, honorable mention all city. And his coach passed away right before they went to the championship. And the players on the team just gave up after that. It was really a sad thing. It made me cry. But he went on to Boise State to become a powerful engineer. I think y'all need to kind of hear what he's saying. It's kind of, when I do the interview, at least I'll share that with you. All right, thank y'all very much. We'll talk to you later.
Thank you, Mr. Wilson.
You're
Thank
very
you.
welcome. You're very welcome, gentlemen. Hold on, Chisholm. You're very welcome. Thank you, Anthony. Hey, listen, Chisholm, could you write me an email? You can include the notes for today. That'd be great. I love reading your notes. You know, I packed all your notes away in a drive last time. So if you want to send them again, I can pack them again.
So I've kind of been behind on like 2 days of emails, so I'll send them out today to catch up. Yeah.
Yeah, no, you're gonna be real busy next 2 days. Sorry, but it's gonna be that way. I need you also to remind me in a separate email. Just say Colby, Kolbe Warfield. Say Colby Warfield, male athletes. Say that. It just occurred to me today, he's an asset. This story is amazing. A lot of these guys, you know, and your brother, I want your brother to see it when I present that. Now I'm going to interview him first, okay?
Mm-hmm.
I want them to get his interview, and then I want him to spend some time with them online or something. And I don't think he's working back east on Wallops Island, where they launch defense satellites, he and him. It's a secret site. He probably the NASA is a cover story, because a lot of these people can't tell me what they're doing.
Mm-hmm.
I have a young lady that's working with dolphins. She's a marine biology major, oceanography major from Rhode Island. She plays little games. I mean, she can't tell me what she's doing. But I read somewhere, I'm not saying it's true, that dolphins, being the smartest mammals, are excellent for underwater surveillance and excellent for bringing cameras underwater to see things, and really good at clearing mines. You know, they've never lost a dolphin. They've cleared over 2,000 mines during the Persian Gulf War. They're super smart. And we don't totally understand how they're taught so easily. And did you know they have an attraction to man that's like cats and dogs? That's why they follow after ships. If you've ever been on ships, they follow them, because they know there's humans on that ship. They're that smart. Whales are smart too, by the way, but they're a little more aggressive. If you get in their territory, they'll knock your boat over. Woo! Anyway, that's your wildlife. Could you write the email first put together a thing of your notes? I know it'll take you a little bit. It's kind of our aftermath stuff here. And then also send me an email, maybe do it first, remind me to get Colby Warfield with these guys. These are just 3 of the 7 or 8 guys I know that need to see him, need to hear his story, need to hear me interviewing him or something. Okay, because I'm going to do an interview with him, but maybe I'll do another one with them present. Okay?
Okay.
All right. Appreciate all you do. Your unique
See
style.
you today, I think.
Huh?
See you later today.
I like the way you put that. Bailey and me are working on where I should be. And maybe it looks like I'm gonna see you late, so we can get the equipment out of there, and me and your brother can discuss our plans for the board.
Okay.
Because Michelle's giving me an answer back on that, because I got to come up with what if it can't fit in her car. I have an idea for that. We have a van at the church. I could drive the van down to Lakewood, load the boards up tomorrow. I'm sure they'll keep them for one night for us. And OC may be a part of that plan. I got to get the most out of him before he goes to school, and I lose it forever. All right. I know you're doing a lot. please try to remember to give me your availability after your contract expires in 2 weeks. Give me an idea of your availability. So I know you're taking some professional training and stuff like that.
Mhm.
Right? Just give me an idea of your availability. Just let me know routinely. Then I
Okay.
can answer your SAT question. You think I'm ignoring you, don't you? I'm not. I'm not ignoring you. I just want to know how to fit you in. Okay?
Yeah.
All right,
Mhm.
okay. I got everything.
Thank you.
So one thing about you, those are the things I like to see you work with. And then let's circle back later this week. If we have some aftermath issues on Lakewood or whatever, we'll let you know. But right now, me, Bailey, and Ileana are dealing with the parents on the after issues, like getting students to finish tests at home, things like that. All right.
Okay.
I'll let you later.
Okay. Bye.